Hi, in this video I am going to discuss Edexcel IAL Unit 2 May-June 2022 paper. Okay, the first question. A ray of light is incident on the boundary between two materials X and Y as shown. This diagram is given on the paper. The refractive index value for material X is Nx. So this material has refractive index Nx and this has refractive index Ny. And there are four different statements are given. The statements related to which row of the table gives the conditions required for total internal reflection to take place at this boundary. Okay, so we should know that to have total internal reflection, the first condition, the light should travel from optically more denser medium to optically less denser medium. Optically more denser medium means where the speed of the light is less, or the refractive index of the medium should be larger compared to the second medium. So this is here the total internal reflection should happen means the refractive index of the first medium, that is X, must be greater than the refractive index of the second medium, which is Ny. That's the first condition. The second condition, the angle of incidence must be greater than the critical angle. Otherwise, what will happen? There will be refraction and partial reflection will happen. So, if the angle of incidence is greater than the critical angle for the boundary of media X and Y, then total internal reflection will happen. So, the conditions are, first condition, the angle of incidence must be greater than the critical angle for the boundary X and Y. The second condition, the refractive index of X must be greater than refractive index of Y. Then only the material X will become optically more denser than the material Y. So that means the second condition, Nx must be greater than Ny. So the correct answer is A. Question number 1, correct answer A. Second question, the graph shows how the displacement x of particles in a wave varies with time t. The speed of the wave is unknown, it's not known. Which of the following cannot be determined from a graph of displacement against time for particles in the wave? First one is amplitude. We can find amplitude from the graph. So this is the amplitude, right? This is the amplitude. So we can find the amplitude from the graph. Both will be the same. For the crest and trough, the amplitude will be the same. So we can find it. The question is which cannot be found from this graph. We can find. So this is not the answer. Second one, frequency. Yes. So this is the time period. So the time taken for one full oscillation, this will be the time period. We know that frequency equal to 1 over t. We can find the frequency from displacement time graph. So that also not the answer. Third one, period. So already I told this is the period. So this is the period. We can find the period of the wave from the graph. That also correct. The last one, answer D, wavelength. We can't find wavelength from displacement time graph. We can find the wavelength from displacement distance graph. Displacement distance graph, from that we can find the wavelength, not from displacement time graph. So for question number 2, the correct answer is D. Okay, the third question, I drew the diagram. Diagram is not given in the question, but I drew it. When a distance between the Sun and the planet Mercury is 4.6 10 to the power 10 meter, the intensity of the solar radiation at the surface of the Mercury is 1.45 10 to the power 4 watts per meter square. Which of the following expressions give the power of the Sun? So you know the equation, power output from the Sun is given by P, and the intensity of that radiation at a distance d from the wave source, or at a distance d from the source, is given by I equal P over 4 pi d square. This equation is given in the data sheet. I equal P over 4 pi d square. This is the power output from the source. Here the source is the sun. D is the distance at which we are measuring the intensity I. Okay, so I we know that 1.45 10 to the power 4 power we need to find it over 4 pi d squared. Distance is 4.60 10 to the power 10 all things squared. So P is given by cross multiply 1.45 into 10 to the power 4 into 4 pi into 4.60 10 to the power 10 squared. So there's an answer given, that is answer B. The correct answer is B for question number 3. Okay, question number 4. A ray of unpolarized light is incident on a polarizing filter. The polarizing filter transmits light of intensity I as shown. So they drew a diagram. So there's a polaroid. Through the polaroid, light is passing. The light falling on the polaroid is unpolarized light. So when the light comes out through the polaroid, it will become plane polarized. Plane polarized light. The question is, the polarizing filter is then rotated in the direction shown. So they are rotating the polarizing filter. So what will happen is the question. So already when unpolarized light falls on the polaroid, the intensity of the light passing through the polaroid, which is already becomes a plane polarized light, its intensity is I, right? When you rotate the polaroid, there's no change in intensity. So that's the method we use to detect whether the light is plane polarized or unpolarized light. When you see an unpolarized light through a polaroid and when you rotate it, there's no change in intensity. That is the experimental observation. But if you see a plane polarized light through a polaroid and when you rotate at a point, you will get a bright light. From that position, when you rotate further through 90 degree, it will become dark. That is for plane polarized light passing through a polaroid. But when unpolarized light passing through a polaroid, its intensity will decrease after passing through the polaroid. The intensity will become less. But when you rotate it, there is no change in intensity, right? So the question is, which of the following gives the intensity of light transmitted after the filter has been rotated through 90 degrees. So I told there is no change in intensity due to rotation of the polaroid. So it will remain same as I. So the correct answer D. If it is a plane polarized light, when it is rotated through 90 degree, it will become 0. No light will pass through it, only for plane polarized light. But this is an unpolarized light. So the intensity will remain unchanged even when you rotate the polaroid. So for question number 4, correct answer D. Okay, so this diagram is given. A diffraction grating and screen are set up as shown. This question number 5. The position of the central maximum is at O. The position of the first order maximum, which is X. The diffraction grating has 30 lines per millimeter. So on 1 millimeter there are 30 slits are there on the diffraction grating. Which of the following expressions gives the wavelength of the laser light? So we know the equation for the wavelength of the laser light. To find it, the equation what we use for the diffraction grating is given by d sine theta equal n lambda, right? So we need to make the lambda subject. We'll substitute the necessary and the required quantities in this equation. Okay, we need to find the D first. So I'll do step by step. Anyway, MCQ, but for your understanding, I'm doing it step by step. So D means number of lines per millimeter. Number of lines per millimeter is the D. So which is given in the given quantity is 300 lines per millimeter. Sorry, D is the distance between adjacent lines. I made a mistake. D is the distance between the adjacent lines is the D. But what is given? Number of lines per millimeter given. So that means we know that in 1 millimeter, there are 300 lines. So the distance between adjacent lines, how much is it? In terms of meters, I can say that D is equal to 1 millimeter, convert to meter, 10 to the power minus 3 meter over 300. That is the D. Then I need to find the sine theta. So sine theta, that is equal to opposite over, that is given, the opposite is given 0.378. This is also given 0.378. So 0.378 over 2.035, that is the sine theta. Now substitute here. What is the value of n? They are saying x is first order. So that's the first order, mean x equal to 1. Okay, so first order mean n equal 1. X is the first order, that means n equal 1. Okay, so substitute these quantities. B I can say 1 into 10 to the power minus 3 over 300 times sine theta 0.378 over 2.035 equal 1 into lambda. So you know already lambda is subject. So the correct answer, lambda is equal to 1 over 10 to the power minus 3, which is on numerator. When it comes to the denominator, it will become 10 to the power plus 3. So 10 to the power plus 3 into 300, that is 300, another 3 zeros, into 0.378 over 2.035. So the correct answer, D. Okay, question number 6. At a point in a circuit, there is a current of 3 amperes. Which of the following gives the total charge passing this point in 2 minutes? Okay, this is like IGCSE standard question. So question number 6, we know Q equal IT. So the current is given 3 amperes. 3 into time should be in seconds. So 2 minutes, 2 into 60. Solve it, you will get the answer. That will be 360 coulomb. Answer D. Okay, question number 7. The diagram is given. The diagram shows an electron transition between two energy levels in a hydrogen atom. Which of the following could not have caused this transition? So we know that the electron is excited from lower energy level, 13.6 is the ground state for hydrogen atom. From lower energy level to high energy level is a excitation. Okay, the atom absorbing a photon with an energy of 13.6 electron volt. The question is careful. Which of the following could not have caused this? Could not have caused it. So atom absorbing a photon with an energy of 13.6 electron volt. Okay, careful. Now, normally you would have learned that when you think about excitation by a photon and excitation by a particle, you know, you can excite an electron in an atom by hitting the electron on the ground state by using a photon, or by using a particle such as electron. You can hit the electron and excite the atomic electron to higher energy level. But there is some difference. There is a difference between excitation by a photon and excitation by a particle such as electron. Now, if a photon wants to excite an electron from ground state to higher energy level, or from one state to higher energy level, the energy of the photon must be exactly equal to the difference of the energy level from where to where the electron is being excited. Careful. So here, because photon never shares its energy with matter, either it will give all its energy to the particle such as electron, or the photon will not give any energy. If the photon gives energy, it never shares its energy with a particle. So if a photon want to excite an electron from this energy level to this energy level, the energy of the photon must be exactly equal to the difference of the energy levels. Otherwise, the photon will not excite the electron from this state to this state. Okay, but a particle such as electron, if you hit the hydrogen electron which is at the ground state, if you hit that electron by using another electron, it can carry any energy, any amount of energy which is greater than the difference of the energy levels. You know the difference of the energy levels here. I can say delta E. The difference of the energy level delta E will be equal to minus 3.4 minus 13.6 minus 3.4. The delta E will be equal to minus 3.4 minus 13.6 electron volt. That will be equal to 10.2 electron volt. So that's the difference of the energy level. So if a photon wants to excite an electron from this state to this state, its energy must be exactly 10.2. Cannot be lower than 10.2. At the same time, cannot be greater than 10.2. A photon with an energy 10.6 or 10.7 cannot excite the electron because photon never shares its energy with matter. Electron is a matter. But a particle such as if an electron comes and hit, if its energy is greater than or equal to 10.2, then it can excite. Say for example, if the energy of an electron is equal to 10.8 or 12, it can excite and give 10.2 electron volt of energy to this atomic electron, and the incoming electron will move with the balance energy. Electron can share its energy with another particle such as electron. Okay, so for example, if an electron, if there's an electron moves at energy of say 11 electron volt, so this electron will give 10.2 electron volt to the ground state electron of the hydrogen and excite it to this level, and this electron will move with the balance energy, the remainder, the balance energy, which is equal to 11 minus 10.2, which is 0.8 electron volt. Electron can share its energy with another electron. Okay, so in that way, the first answer given in the paper, the atom absorbing a photon with an energy of 13.6 electron volt will not excite the electron of hydrogen from this state to this state because the energy of the photon 13.6 is greater than 10.2. So that cannot be the answer. That is the answer. Sorry, that is the answer, because question is which of the following could not have caused it. So a photon with 13.6 electron volt cannot excite this electron from here to here. We'll check the other answer also. The statement B, the atom absorbing a photon with an energy of 10.2. Yes, if the photon has exactly equal to the difference of the energy levels, then it can excite. So that will happen, right? Answer C, an electron with a kinetic energy of 13.6. Yes, it can, because if the electron carries an energy of 13.6 electron volt, okay, if the electron carries an energy of 13.6 electron volt, then it will give 10.2 electron volt to the atomic electron, the hydrogen electron, and it will go with the balance of 13.6 minus 10.2. With that energy, it will continue its motion. So that will happen. That can excite. So answer C also not the correct answer for us, because the question is which cannot happen. The last one, an electron with a kinetic energy of 10.2, yes, that also can excite it. So question number 7, the correct answer which cannot cause this excitation is answer A. Answer A is the correct answer. Okay, this circuit diagram is given on question 8. A battery is connected to identical uniform nichrome wires PQ and RS, so identical wires. A voltmeter is connected to the wires as shown. So voltmeter is connected from this point to this point. So this point is at a distance of 0.25 meter from P. This is at 0.75 meter from R. The battery has negligible internal resistance. The question is which of the following is the reading on the voltmeter? Okay. You know, voltmeter reads the potential difference, or voltmeter reads the voltage across 2 points. So here the voltmeter is going to read the voltage across this point. I can call this point X and this point Y. So the voltmeter will read the voltage across, or potential difference between the points X and Y. Okay, so what could be the potential difference between X and Y? Now when we consider the wire PQ, it's a uniform wire, means its area of cross-sectional area is uniform. We know that R equal rho L over A. If the area of cross-section is uniform, and we know for a given material rho is constant at a constant temperature, so rho over A will be constant. Rho over A will be constant. So the resistance, I can say resistance is directly proportional to length of the wire for a uniform wire. So resistance is directly proportional to length. And also we know that according to potential divider method, the voltage applied across P and Q will be divided across Px and Xq at the ratio of their resistance. But we know that ratio of the resistance is equal to ratio of their length. I showed it here. So that means the potential difference across Px to Xq will be equal to the ratio of their length. Okay, so I can find the potential difference across point P and point X. That is, I can say the potential across P and X between point P and point X is equal to, I can use the potential divider method in terms of length, not in terms of resistance, because I'm going to use the length because resistance is directly proportional to length. So the total applied voltage is 4 volt given on the question paper. So VPX, the potential across PX is equal to 4 into, I'm using the potential divider method, 4 into this resistance, means this length 0.25 over 0.25 plus 0.75, that is 1. So that is going to be the VPX, voltage across PX is going to be how much? 4 into 0.25, that is 1 volt. Right. Same way, what is the potential across R and Y? Potential across R and Y, how much will be? Between R, Y, how much is it? That is going to be 4 into 0.75 over 1. That's going to be 3 volt. Right. We know that we need to find the voltage across X and Y. We need to find the voltage across X and Y. That's the voltmeter reading, right? We know that voltage at P and voltage at R are the same because this connecting wire has no resistance. So no potential drop across between the point P and R. So P and R will have the same potential. So I can say voltage across P and X is 1 volt. Voltage across R and Y is 3 volt, means I can say voltage across P and Y is 3 volt. I can say this as voltage across P and Y is 3 volt because P and R have the same potential. No resistance for this connecting wire. That means no potential drop. So voltage across P and X is 1 volt. Voltage across P and Y is 3 volt, means what's the voltage across X and Y? The difference between these two, that is 2 volt. Voltage across X and Y is 2 volt. The difference between the points, the voltage across X and Y, that will be the voltmeter reading. So correct answer B. That's the correct answer. Okay, question number 9. The number of conduction electrons in a light dependent resistor changes as light intensity increases. Which of the following best explains how the number of conduction electrons changes? You know, LDR, light dependent resistor, is made of semiconductor. So you know when light photons falls on the semiconductor, the electrons will absorb the energy from the photons and they will be excited from valence band to conduction band. So the electrons in the conduction band will increase. So when the electrons in the conduction band increases means charge carrier density will increase. When light increases, the intensity of the light increases, number of photons falling on the LDR will increase. You know, one photon excites one electron, so the number of electrons excited from valence band to conduction band will increase, so charge carrier density will increase. So what happens? The resistance will decrease. So the correct answer C, it increases because electrons gain energy from the photons of light. That means electrons gain energy means electrons will absorb the photons, or photons will hit the electrons and excite them from valence band to conduction band. So electrons are excited from valence band to conduction band means they absorb the energy of the photons and they will be excited. So question number 9, correct answer C. Okay, question number 10. In 1927, G.P. Thomson first demonstrated that electrons passing through a nickel crystal produce a diffraction pattern. Which of the following can be concluded from this observation? Okay, so when we are using electrons to probe crystal means we use the wave nature of the electron, not the particle nature. We use the wave nature of the electron to study the crystal structure. We call that is crystallography. So there the wave nature of the electron will be used. You know, the wavelength of the electron is given by, according to Broglie theorem, it's given by lambda equal h over p or h over mv. And in this in this experiment, the wavelength, that means the wavelength associated with the electron must be equal to interatomic spacing if you are studying the crystal structure. Anyway, we are using the wave nature of the electron to study the crystal structure. So correct answer B. So question number 10, correct answer B. Okay, section B, question number 11. The diagram shows a ray of light incident on a glass block. Complete the diagram to show a path of the ray as it enters the block. Use the space below for any calculation. So here the it's not mentioned, it's drawn according to scale, but you need to measure the angle of incidence. So draw a normal here and measure this angle by using your protractor. You will get somewhere 54, 55 degree. I got 54 degree. That's my angle of incidence. Okay, so the question is, you complete the diagram to show the path of the ray as it enters the block. Use the space below for any calculation. So you need to calculate and draw by using protractor. So I know that n1 sine theta 1 equal n2 sine theta 2. That's the Snell's law. N1 is the first medium from where the light is entering. N2 we normally take the light to which it's entering. So N1 is air. So you know that refractive index of air is 1. Not exactly 1, but we take it as 1, right? So 1 into sine 54 equal to N2 is the refractive index of glass. So that is 1.58 into sine theta 2. That is the angle of refraction inside the glass. So find the theta 2. You will get theta 2 is 30.8 degree. So by using protractor you can't measure 30.8. So you need to draw for 31 degree approximately. 31 degree. So here measure the angle 31 degree inside the glass and complete the diagram. So 31 degree, something like this, you will draw it. That's the question A part. That's the answer for the A part. B part, the speed of light in a different type of glass is 1.96 10 to the power 8 meter per second. calculate the value of the critical angle at a boundary between this type of glass and air. Okay, so uh, normally students use the equation what they used in O level. Yes, nothing wrong here, you will get correct answer. But sometimes if the two media are different, none of them are air, then you might go wrong. So normally I usually tell the students to use this equation, same equation, N1 sine theta 1 equal to N2 sine theta 2, right? So here the critical, calculate the value for the critical angle at the boundary between this type of glass. So the critical angle will occur when light travels from glass to air. Optically more dense to optically less dense. Optically more dense means where the refractive index is higher compared to the second medium. So the critical angle will happen when light travels from optically more denser to less denser. So there when the light travels from glass to air, the critical angle or total inner reflection can happen, right? So I can see N1 here, the glass, Ng sine theta 1 equal to N air sine theta 2, right? So critical angle means the angle of refraction in the second medium should become 90 degree. So the critical angle means when light travels from optically more denser medium to less denser medium, the angle of incidence which makes the angle of refraction 90 degree, that angle of incidence is called critical angle. So Ng, the refractance of glass, we know 1.58 sine C, which is happening inside the glass, which is the optically more denser medium, is equal to air 1 into sine 90. Now solve it. Sine 90 equal to 1. So find the sine C. So sine C equal to 1 over 1.58. C equal, you will find the angle, that will be 40.8 degree. So in this question, if you directly use this equation, sine C is equal to O level IGCSE, you learn sine C equal 1 over n, nothing will go wrong. You will get the correct answer in this question. But it might give trouble if the two, none of the medium is air. Say for example, if there is a question something like this. This is the first medium, its refractive index is for example 1.63. This is the second medium, 1.28, something like that. We'll think about two different media, 1.68 and 1.28. So here if they ask to find the critical angle for the boundary of the two different media, if you use this equation n equal sine C equal 1 over n, you might go wrong. So in this question you must use, you know, the light, this is optically more denser medium, optically less denser medium. Light should travel from optically more denser to less denser, then only you will have critical angle. So in that situation the light will happen like this. The light will go like this. It will go along the boundary. This is the critical, this is the angle of refraction 90 degree. This is the critical angle. So here you should use N1 sine theta 1 equal N2 sine theta 2. N1 is 1.68 sine C equal 1.28 sine 90. Here if you solve, you will get the critical angle for these two media. Okay, so if you use, in this question if you use sine C equal 1 over n or something like that, you might get in trouble, you will go wrong. So better use this equation even when there is a question related to critical angle. So like what I did here. Okay, question number 12, these two diagrams, circuit and a graph are given. The graph for variation of the resistance of a thermistor with temperature. The question determine the millimeter reading when the temperature of the thermistor is 54 degree. So from your graph, from at 54 degrees Celsius, read the at 54 degrees Celsius from your graph, find the resistance. You will get the resistance is 1000 ohms. I got 1000 ohms from the graph. So at 1000 ohms, the resistance is, at 54 degrees Celsius, the resistance is 1000 ohms. That is 1 kilo ohm, right? So RT the resistance of the thermistor is equal to 1000 ohms, which is 1 kilo ohm at 54 degrees Celsius. The question is find the total resistance or milliammeter reading. So first we need to find the equivalent resistance of it. So these two are in series connected because you know voltmeter, the current flow through the voltmeter is negligible. So even when the voltmeter is connected, the inter-resistance of the voltmeter is very large. So the total resistance of the thermistor and the voltmeter, the equivalent resistance has no change because inter-resistance of the voltmeter is very large. Because of that, the equivalent resistance of the thermistor and the voltmeter will remain as same as the resistance of the thermistor because inter-resistance of the voltmeter is very large. Otherwise, if the voltmeter has a lower resistance, we need to find the equivalent resistance of these two. Here we don't have that problem. So the 3 kilo ohm and the thermistor are in series. So their total resistance, I can say R is equal to 3 plus 1, 4 kilo ohm. This equivalent resistance is in parallel with 2 kilo ohm resistor. You know there are two junctions. So this combination, the equivalent of 3 kilo ohm and the thermistor is in parallel with 2 kilo ohms. So 1 over R naught equal 1 over 2 plus 1 over 4. So R naught will be equal to 4 by 3. That is 4 by 3 kilo ohm. That is 4000 over 3 ohms. The question is find the milliammeter reading. So the circuit, the voltage is 12, the EMF. So I need to find the current flow. I know the equivalent resistance, that is 4000 over 3 ohms. So I can use V equal IR for the equivalent resistance, IR naught. So the voltage applied across the equivalent resistance of the circuit is 12. I need to find the current flow. R naught is 4000 over 3. So I will be equal to, the current flow will be equal to 36 over 4000 amperes. So this is milliampere. I need to multiply this by 1000 to get the milliamperes. So I is equal to 36 over 4000 into 1000 milliamperes. That will become 9 milliampere. So the reading of the voltmeter ammeter, milliammeter will be 9 milliamperes. That's the answer for A part. Question number 12, A part. Okay, question number 12, B part. B part, first part. Explain how decreasing the temperature of the thermistor affects the voltmeter reading. Do not include calculations in your answer. So you know that decreasing the temperature of the thermistor. So when the temperature of the thermistor is decreased, you can see the resistance according to the graph. The resistance of the thermistor will increase. When the resistance of the thermistor increases, the total resistance of 3 kilo ohms and the thermistor, those are connected in series, their total resistance will increase. But the question is about how it will affect the voltmeter reading. Okay, so look at here. The voltage across the junction is equal to 12 volt. The 12 volt is applied across the junction. That means the total voltage applied across 3 kilo ohm and the thermistor is 12 volt. I can redraw this diagram for B part, first part. I can ignore the 2 kilo ohms because the voltage applied across the junction is 12 volts. I'm going to consider circuit below the junction. So I can imagine that circuit like this, 12 volt, 3 kilo ohm. Here is the thermistor. And here is the voltmeter. I am not considering this 2 kilo ohm because I don't want that in this question. Okay, so in this one, when the temperature decreases, resistance of the thermistor will increase. So The voltage across both, the total voltage is 12 volt. They are connected in series. So the total voltage will be divided across these two components at the ratio of their resistance. So since the resistance of the thermistor increases and the total voltage applied across them remains constant, what happens? The voltage across the thermistor will increase when the temperature decreases. Therefore, the voltmeter reading will increase. Okay, question number 12, B part, second part. Explain how decreasing the temperature of the thermistor affects the power dissipated by the 2 kilo ohm resistor. Do not include any calculation. Okay, so what happens? Whatever happens here, whatever the change in resistance happens here, there's no change in the voltage across 2 kilo ohm, because 2 kilo ohm is directly connected across the junction and the voltage across the junction is directly equal to 12 volt. So voltage across the 2 kilo ohm resistor has no change. What happens? Whatever the thing happens, whether the resistance of the thermistor increase or decrease, whatever happens, the voltage across the 2 kilo ohm resistor will remain the same. So according to P equal V squared over R, the power dissipated 2 kilo ohm will remain the same. There is no change in the power dissipated in the 2 kilo ohm resistor. Okay, question 13. The photograph shows a thin coiled tungsten wire used in a filament bulb. Complete the sketch to show how the current varies with potential difference for a filament. You know, filament is the tungsten is a metal. When temperature increases, you know that atomic vibrations and the collision among the electrons will increase. So resistance will increase, right? So since the resistance increases, when you think about current voltage graph, the graph will turn towards the voltage axis. So the A part, the graph will be current voltage graph for metal or conductor or filament lamp will be like this. It will turn towards voltage. A small portion could be straight line, then it will burn toward voltage axis. B part. The tungsten wire has a diameter of 0.4046 millimeter and a length of 580 millimeter. When emitting light, there is a current of 0.44 ampere in the filament and the potential difference 140 volt applied across the filament. Calculate the drift velocity V of the electrons in the tungsten wire. Number of charge carrier per meter cube, that is the charge carrier density, is also given as 1.26 10 to the power 29. So B part, we need to use I equal NAEV. I need to find the V, the drift speed. So I is 0.44, N is given as 1.26, 10 to the power 29. The area of cross section is not given directly, but the diameter is given 0.046 millimeters. So the radius will be half of it. So you know pi r squared. So pi into the radius is 0. Yeah, it's given in millimeters. So I need to convert to meters. 0.023 into 10 to the power minus 3 meter, all things squared, pi r squared, into charge of an electron, which is E 1.6 10 to the power minus 19 into V. Find the V, you will get the answer. That will be 0.013 meter per second, or you can say 1.3 centimeter per second. That's the Answer for B part, first part. B part, second part. When the potential difference across the tungsten filament is 140 volt, the current in the filament is 0.44 ampere. The table shows resistivity values for the tungsten at different temperatures. Deduce the temperature of the filament. So we use, we know the drift speed, we don't need that for second part. We know the current, we know the resistance. So B part, second part. We can use R equal V over I. We know the voltage applied across it 140 and the current flow we know that 0.44. So the resistance will be 318.2 ohms. I need to find the resistivity. So R equal rho L over A given on the data sheet. R is 380.2. I need to find the rho. Length of the wire, the filament is given. The length is 580 millimeter. Convert to meter. Minus 3 over. Area of cross section. Again, I need to find pi r squared. R is 0.023 into 10 to the power minus 3 all the square. So rho you will get 9.11. 10 to the power minus 7 meter. So when you check it, compare it with the table given, 9.11 is closer to 9.04 10 to the power minus 7. That is the fourth column in the table. So the temperature will be equal to 2700 Celsius. Okay, question 14 is about two different waves generated during earthquake, P waves and S waves. There are two new equations given but nothing harder because all the quantities are given. Just substitute to get the first part of A part. So the density of the materials is given 2700 kilogram per meter cube. So just substitute and you will get the answer for Vp and SP, Vs. Vp and Vs are the speeds of the P wave and S wave. There is an equation given, we'll accept it. Don't worry about anything beyond that. So Vp is given as square root of K plus 4 by 3 G over rho. So substitute square root of K is given 7.55 10 to the power 10 plus 4 by 3. G is given 2.61 10 to the power 10 over density is given 2700. Solve it, you will get the answer. That will be 6391. So I can say 6392 meter per second. If you want to give it in 2SF, 6400. I can give 2SF if I give it 400 meter per second. Then for Vs is given as square root of G over rho. So those quantities are given, square root of 2.61 10 to the power 10 over 2700. So that will be equal to 3109 meter per second. Or if you want to give it in 2SF, 3SF, 3110 SF, you can leave as it is. Okay, that's the answer for question number 14, A part, first part. Question number 14, A, second part. The earth consists layers of liquids. The value of G for liquid is 0. Value of G for liquid is 0. Explain whether S wave can travel through liquids. So S wave just depends only on G and rho. So if the G becomes equal to 0 for liquids, the speed of the S wave will be equal to 0. Speed of the S wave 0 means the wave has no speed, means it won't travel or transmitted through liquids. That's the answer. So I don't need to write that answer. You can say according to. So second part you can say so that means S wave cannot travel through liquid. So what about P wave? Yes, P wave can travel because P wave for liquid G0, then the speed of the P wave when this becomes 0 will be equal to square root of K over rho. So P wave can travel through liquids but S wave cannot travel. Okay, B part. During a single earthquake, S waves can be produced by more than one source. If two coherent S waves meet, interference can take place. Explain what is meant by coherent. So, you know all the textbooks shows this answer. So, B part, first part, what is coherent wave? The answer should be like this, 2 marks. First mark will be given normally for the waves with same frequency, 1 mark, with constant phase relationship, second mark. Waves with same frequency and constant phase relationship. That's the answer. Same frequency and constant phase relationship. So that's a full marks. You will get it 2 marks. Right. Second part. A scientist created a model to predict the effect of two coherent S waves at different distances from the source. The model predicted the amplitude of the S waves at points A and B shown on the diagram. So there's a diagram given. The amplitude of the waves at position A was 0. The amplitude of the waves at position B was greater than 0. Okay, so this diagram is given. Explain why the amplitude of the waves at position A was 0. So you can say like this. So what is happening? The waves generated by the two coherent sources will travel towards position A and position B. At position A, the question says the position A, the amplitude is equal to 0. That means, you know, when wave two source interference, we normally call two source interference, the wave generated by two coherent sources, they will travel different distances, so there will be path difference. Path difference is the difference between the distance traveled by the waves. So we can say at position A, the path difference of the two waves is equal to odd multiple of lambda by 2. So if the path difference of the two waves traveling from these two sources, when they reach position A, the path difference will be equal to odd multiple of lambda by 2. So if the path difference is odd multiple of lambda by 2 means the phase difference will be equal to either pi or odd multiple of pi, like it could be pi or 3 pi, 5 pi and so on. So when the waves overlap antiphase, so they will overlap antiphase. So if the waves overlap antiphase, destructive superposition will occur, and during destructive superposition, if the two waves have the same amplitude, the resultant amplitude will become equal to 0. Okay. Okay, question number 15. This circuit diagram is given. The diagram shows a circuit containing three identical resistors A, B and C. So all three are identical resistors A, B and C. The cell has negligible internal resistance. Explain, the A part is an explaining question for 6 marks. Explain how measurements of current and potential difference could be used to demonstrate that charge and energy are both conserved in this circuit. Your answer should refer to resistors A, B and C. Okay, so explain how measurements of current and potential difference could be used to demonstrate that charge and energy are both conserved in this circuit. Your answer should refer to resistors A, B and C. Okay, so we can talk about the current flow. We can say about 3 ammeters are connected, we can say, or we can say the current flow through the, we can put 3 ammeters here. You can put an ammeter here if you want, and here you can say the ammeter here, A2, here another third ammeter, A3. 3 ammeters are connected to measure the current flow, and you can measure voltage. So the measurements is about the measurement. So we need to measure the current and voltage here. So we can connect a voltmeter here that measures the EMF V1. Here you can connect a voltmeter across it, that is V2. This is V1. Here there is a voltmeter, that could be V3, and here V4. Okay, so we can say like this, how the energy and charge. So we can say current flow. First you should say current is the rate of flow of charge. That means the amount of charge flown per second. You know Kirchhoff's first law. Kirchhoff's first law says the current from the cell. If I say that current is I1, that current I1 will be equal to I2 plus I3. So that you can find it by using the ammeter readings. The current which is coming out of the cell is A1. The reading of A1, I can say reading of A1, ammeter A1 will be equal to reading of A2 plus reading of A3. So first you should say what is current, rate of flow of charge, amount of charge flown per second. So the amount of charge flown through the cell, or the amount of charge given out from the cell, that is read by A1, that will be equal to the amount of charge flowing to the resistor A and the amount of charge flowing to the resistor B, that is the reading of A2 and A3. First you can say this one. Secondly, about the energy. What is energy? I can explain the energy in 2 different ways. I can explain the energy based on power, P equal VI. P equal VI. What is power? Amount of energy per second. So we know that power generated by the cell, which is given by P equal EMF times I. So first we can see the voltmeter V1 reads the EMF. So the voltmeter reading V1 multiplied by the ammeter reading A1 will give the power generated by the cell, that is the energy per unit second. Then the voltage across the resistor A is recorded by the voltmeter V3. Voltage across the resistor B is recorded by the voltmeter V4, and the voltage across the resistor C is recorded by voltmeter V2. And we know the current through the resistor A, which is A2, this is A3, and the reading of this current is same as K1. So the power, that is the energy per unit time dissipated in resistor A is given by P equal VI. P equal VI. So I can say voltmeter reading of A2 multiplied by voltmeter reading of V3 multiplied by ammeter reading of A2 plus voltmeter reading of V4 multiplied by ammeter reading of A3 plus voltmeter reading of V2 multiplied by ammeter reading of A1. They all, when you add, that will be equal to voltmeter reading V1 multiplied by A1, that is the power generated by the cell. So by this reading we can show that. So first one, to show the energy, we can show by using, as I explained, by using P equal VI, energy per unit time. The other one is in terms of just only the voltmeter reading. What is it? Just only the voltmeter reading means, you know, W equal QV, that is V equal charge, Q is W equal QV, you know that. So V is equal to, W equal QV, that is equal to, V is equal to W over Q, that is amount of charge flown per second, the work done per, or energy per coulomb. We can say energy per coulomb is the voltmeter reading. So when you think about energy per coulomb, this is the energy per coulomb, that is the voltage across the cell, that is equal to voltage across the junction, that is one of the resistors voltage plus the voltage across the resistor C. That way also we can explain the voltage of resistor A or voltage across resistor B plus voltage across resistor C, that will be equal to voltage across the cell. So that means voltage means joule per coulomb, work done per coulomb. That way also you can explain either in terms of voltmeter reading alone you can explain, or by using multiplication of voltmeter and ammeter reading, that gives the power, that will be the power generated by the cell is equal to power dissipated across it, power dissipated across it, power dissipated across it. Power means energy per unit time. That way also you can explain. I feel the energy per unit second is better way of explaining it. Okay, so question number 15, B part, first part. Calculate the total resistance of the circuit, resistance of each resistor 12.5. So all three are identical resistors, each of them have resistance of 12.5 ohm. So we need to find the equivalent resistance. So it's that simple. These two are connected in parallel because they are connected across these two junctions. Then with that equivalent resistance, this is connected in series. I need to find the equivalent resistance of the circuit. So I can say 1 over R equal 1 over 12.5 plus 1 over 12.5. That's the equivalent resistance of these two, A and B. So from that I can say R is equal to 6.25 ohms. With this equivalent resistance of these two, the resistor C is connected in series. So the final overall equivalent resistance R naught equal 6.25 plus 12.5, that will be equal to 18.75 ohms. That's the answer for B part, first part. B part, second part. The resistors are connected to a different cell with EMF epsilon. They are giving the circuit again as shown. So the same circuit is given again. The cell has an internal resistance. So it has internal resistance. Now earlier they said it has no internal resistance. Now the question says it has internal resistance. Describe how a single ammeter reading can be used to determine the internal resistance of the cell. You should add to the diagram to show the position of this ammeter. Okay, so in this question, second part, I'll draw this, I use the same diagram. So second part, the same diagram is given. Now they are saying this cell has an internal resistance. That is not shown on the diagram. I am putting the internal resistance here. So it has internal resistance, but that diagram is not given. I included it because they are saying it has internal resistance. EMF is a known quantity. The EMF of the cell is a known quantity, which is epsilon. Okay, I can take only one reading, that is current reading. Where should I connect the ammeter? By using that ammeter, just one reading, how can I find the internal resistance? Okay, for that part, I need to find the current coming out through the cell. So I should connect the ammeter here. So I should connect the ammeter in series here. So if I connect the ammeter here, then I will be able to find the current flowing through the cell, right? They are saying the EMF is a known quantity, and we know all these three resistors have 12.5 ohms, and we found the equivalent resistance of these three as 18.75. So I can replace all these resistors by 18.75 ohms. So that is the equivalent resistance. So I know this 18.75 ohm is a known quantity because already in the previous part we found it. So ammeter should be connected here. I removed all these three resistors and I connected the equivalent resistance of those three resistors, which is 18.75 ohms. How can I find the R? So it's simple. I know the EMF, it's given. I know the ammeter reading. So if I connect ammeter reading here, I can measure the voltage across the 18.75 ohms. That will be the terminal potential difference. So the terminal potential difference V, that will be equal to 18.75 into the ammeter reading. I can say the ammeter reading is equal to I. Ammeter reading is I is the ammeter reading. That is a known quantity. So I know the V, the terminal potential difference, but I know V is equal to EMF minus IR. So I need to find the R. V is a known quantity. So I can say 18.75 into I equal to EMF is also a known quantity minus IR. Make R subject. R will be equal to EMF minus 18.75 I over I. This I can write EMF over I minus 18.75. From this I can find the internal resistance of the cell. Again I'll explain. The equivalent resistance we know 18.75. I should connect the ammeter here. So the ammeter reads the current coming out through the cell. So terminal potential difference is the voltage across the terminals of the cell. Voltage across the terminals of the cell will be same as the voltage across the 18.75 ohms. So I can calculate the terminal potential difference by using 18.75 is a known quantity. Ammeter reading which I take as I, that also a known quantity. So the terminal potential difference, I know that. So we have the equation terminal potential difference is equal to EMF minus IR. So V I can replace by 18.75 into I. EMF is a known quantity minus IR. I need to make the R subject. I need to find the R. Just one reading I took it, that is the ammeter reading. So R is equal to EMF minus 18.75 I divided by I. So this I can write partially EMF over I minus this I will get cancelled 18.75. From this I can find the internal resistance of the cell. Okay, so the diagram is given. Question 16 is about related to stationary wave on a stretched string. So electrical vibrator generates wave, it reflects from the pulley. So the A part, explain how a stationary wave forms on the string. It's a very common question, several times it came. So we can say the electrical vibrate generates a progressive wave or traveling wave. That wave will be reflected back at the pulley, because pulley, the string is touching the pulley, so the wave cannot continue its motion beyond the point where it touches the pulley. It will reflect back, because if the wave cannot move further beyond the point where the string touches the pulley, it can't travel beyond it, so it will reflect back. A certain amount can be lost in the form of sound, but anyway, most of the wave energy will be reflected back. Now there are two identical oppositely traveling waves. What are they? The wave generated by because the electrical vibrator is continuously generating waves, progressive waves. That wave is traveling this way. The reflected wave is traveling in opposite direction. Both will have the same frequency. That will be equal to frequency of vibration of the electrical vibrator. Frequency of vibration of the electrical vibrator is same as the frequency of the progressive waves. There are two identical oppositely traveling waves. They overlap. When they overlap, at certain points they always overlap in phase and produce antinode due to constructive superposition. At certain points they always overlap antiphase and produce node due to destructive superposition. That's the answer you should give for the first part. Okay, question number 16b part. This diagram is given again. The frequency of stationary wave is 30 Hertz. What do you mean by frequency of stationary wave? You know, during stationary wave, each and every antinode and all the parts will vibrate except the node. All the portion between the two nodes will vibrate. So the frequency of vibration of this portion and this portion, that is between two nodes, all the points will vibrate with different amplitudes. So the frequency of those points vibration will be equal to frequency of the traveling wave. Frequency of the traveling wave will be equal to frequency of the electrical vibrator. Remember that frequency of the electrical vibrator will be the same as the frequency of the traveling waves. I told there are two identical oppositely traveling waves that causes, or the superposition of two identical oppositely traveling waves superpose and produce the stationary wave. So frequency of the electrical vibrator is same as frequency of the identical oppositely traveling waves. So frequency of the stationary wave means between two nodes all the points will vibrate. Each of their frequency of vibration will be same as the frequency of the electrical vibrator or frequency of the identical oppositely traveling waves. So here they are saying the frequency is given as 30 Hertz. So frequency is given as 30 Hertz. The mass which is attached here is given as 0.30 kilogram and also given as mass per unit length. So mass per unit length we normally use mu, that is given as 2.27 10 to the power minus 3 kilogram per meter. The question is, the frequency of the stationary wave given 30 Hertz, the distance between the vibrator and the pulley is 3.6 meters. A point R on the string, which is 0.6 meters from the pulley, where the string is touching the pulley, from that point 0.6 meter, determine whether there was a node at R. So the question is, the point here, will there be a node? Okay, so they are not asking to find anything, calculate anything. They are asking at point R, can there be a node? Okay, to decide it, I should know the wavelength of the traveling wave. We know the distance between two adjacent nodes is equal to lambda by 2. What is lambda there? Lambda is the wavelength of the two identical opposite traveling waves. The traveling waves opposite direction, their wavelength is lambda, means the distance between two adjacent nodes will be lambda by 2. I need to find the lambda. Then I will, by using that, I can check what's the, will there be a node formed at R. So for that, first I need to find the speed of the traveling wave. Speed of the traveling wave on a stretched string, speed of the transverse wave on a stretched string is given by V equal square root of T over mu. T is the tension, that is due to the 0.30 kilogram, that is 0.30 into 9.81, that will be the tension per unit length is 2.27 10 to the power minus 3. So I will get the speed of the transverse wave on a stretched string, that will be equal to 36 meter per second. Okay. Now I told that distance between adjacent nodes. I know that at this point where the string is touching, I'll call that point Q, means at Q, I know node will be formed, because the wave which is traveling generated from here can't pass the point Q and come here, because at point Q the string is touching the pulley, so the wave can't travel beyond it. So certainly point Q will be at rest, Q will be a node, right? So I'll find the wavelength of the traveling wave. So V equal F lambda for the traveling wave. So there are two identical traveling waves are there. For one of it, I am using V equal F lambda. So speed of the traveling wave, I found it 36. Frequency, the question paper says frequency of the stationary wave, careful. That will be same as the frequency of the traveling wave, that will be the same as the frequency of the vibrator, I already explained it. So that is 30 into lambda. So from that, find the lambda. So lambda will be equal to 36 over 30, that will be 1.2 meter. So wavelength is 1.2 meter. So distance between adjacent node, between two adjacent node, that will be equal to how much? Lambda by 2, that is lambda by 2, that is going to be 0.6 meter. But I know that at Q means the where the, you can mark it on the answer paper, Q is the point where the string is touching the pulley. At Q, node will be formed. Certainly I know that, because that point can't vibrate. At Q, a node will be formed. So I know the lambda by 2 is 0.6. Here node will be formed. So from here the next node will be formed at a distance of 0.6 meter. So certainly at R node will be formed. So at Q a node will be formed, since the point R is at a distance of 0.6 meter, which is lambda by 2, a node will be formed at R. Okay, part C, the mass M was changed and frequency of their vibrator was adjusted so that a different stationary wave formed on the string, Adjacent nodes were separated by 0.4 meters. So earlier we found the distance between two adjacent nodes. We found it as 0.6 meter. Now it has become 0.4 meter. So they are changing the speed of the transverse wave by changing the mass hung on the string. The diagram shows 2 points S and T. So these are the S and T 2 points on the string at an instant when the string was straight. Explain the phase relationship between points S and T. So phase relationship between S and T, you can see S and T are on either side of a node. So when you think about 2 points on either side of a node on a stationary wave, so if I say this is a node, any point on either side of a node will be always antiphase among them. Always any 2 points on either side of a node will be antiphase. They will oscillate exactly in opposite way. But all the points between two nodes will be in phase. All these points will oscillate exactly the same way. When this comes, this will come, this will come, this will come, like that. Always these points will be in phase among them. But any point on the right side of the node and on the left side of the node will be among them antiphase. They will vibrate in opposite direction to each other. So the answer, I don't need to write, you can say first point, the points S and T are on either side, or you can say S is on the left side of the node and T is on the right side of the node. So first tell that one, S is on the left side of the node and T is on the right side of the node. 1 mark you will get it. Therefore, they will always oscillate antiphase among them. That will be the second mark. So that's the answer for question C, first part. Question C, second part. Explain how the amplitude of vibration of the string at point S compares with the amplitude of the vibration of the string at point T. Okay, so they are saying distance between node to node in this part C is 0.4 meter. So from node to node 0.4 meter means node to antinode will be 0.2 meter. So from the node, point S is at 0.2 meter. So S is an antinode. So S is an antinode that will have the oscillation with largest amplitude or maximum amplitude. But T is at a distance of 0.1 meter, 0.1 meter. So its amplitude will be certainly lower than the amplitude of S. You can tell that. So I am not writing that answer also. So second part, just 2 mark question, you can say, since point S is at a distance of 0.2 meter from the node, it will be an antinode. Therefore, it will have a larger amplitude of oscillation. Point T is at a distance of 0.1 meter, means it's somewhere between the node and antinode. Therefore, the amplitude of oscillation of point T will be smaller than the amplitude of oscillation of point S. I hope you understood that one. Okay. Okay, question 17. Ultraviolet light is incident on a zinc plate. If the photon energy is greater than the work function of the zinc, electrons are released. State what is meant by work function. You know that. You can find it in all textbooks. So you know minimum amount of energy. The word minimum must be there. Minimum amount of energy required to remove, or minimum amount of energy of an electromagnetic radiation to remove an electron from the surface of metal. So the work function is defined for the surface of metal. So you can write minimum amount of energy of an electromagnetic radiation required to remove an electron from the surface of metal. That's the answer for A part. That will be the work function. B part, so they are giving 3 different ranges of ultraviolet radiation, UVC, VA. So the ranges are given. The minimum de Broglie wavelength of the released electrons, you know when light falls on a metal, the metal will be emitting electrons, or the electrons will be released from the metal according to due to the photoelectric emission. So the electrons, those are emitted, has a kinetic energy. they have momentum. So kinetic energy means they will have momentum because they have speed, they have mass, so they will have momentum. So if they have momentum, so there will be a de Broglie wave associated with the particle. So you know that de Broglie wave means, you know, matter wave. We call matter wave associated with the particle is given by lambda equal h over mv. So the wavelength of a matter wave associated with the particles given by lambda equal h over p or h over mv, where h is the Planck constant, p is the momentum, so mass is the m is the mass of the particle, and v is the speed. So here they are saying the electron is released with a particular speed, so it has momentum, so it has a de Broglie wavelength. De Broglie wavelength is associated with that electron according to de Broglie theorem. So that minimum wavelength is 1.50 10 to the power minus 9 meter. Deduce whether the ultraviolet light incident upon the zinc plate is the three different type of ultraviolet radiations are given. We need to identify which ultraviolet radiation falls on the metal to release an electron that has de Broglie wavelength of 1.50 10 to the power minus 9 meter. The work function of the zinc also given, nothing actually. Instead of giving the maximum speed or instead of giving the kinetic energy, if we know the kinetic energy of the fastest electron, we can use, you know, Einstein's photoelectric equation, HF equal 5 plus Ke max. To find the Ke max, they are giving the de Broglie wavelength, nothing. So from the de Broglie wavelength, we can find the speed, that's all, nothing complicated, so simple. So we know that lambda equal h over mv or h over p, I can say that. So here they are saying the wavelength is the minimum. So lambda minimum means, so from this I can say lambda becomes minimum. I'll write h over p, h over mv momentum. Lambda minimum means h over m into v max. So that means the minimum wavelength correspond to the electron with maximum speed. So you know the electrons with maximum speed are from the surface of the metal. Highest kinetic energy, electrons with maximum kinetic energy will be released from the surface of metal. So they will have the lowest de Broglie wavelength. This becomes maximum, this will be the minimum. So I can find the Vmax here directly. So lambda minimum, we know that is given as 1.50 10 to the power minus 9 equal to Planck constant given on the data sheet 6.63 10 to the power minus 34. Mass of the electron given on the data sheet 9.11 10 to the power minus 31 into V maximum. So V max equal, you will get it 4.85 10 to the power 5 meter per second. Right, so we'll use the Einstein's photoelectric equation. HF equal 5 plus Ke max. But we know that frequency equal C over lambda. Therefore, Hc over lambda equal 5 plus half m V max squared. We need to find the work function. Okay? We need to find the wavelength, lambda. Okay, so here 6.63 10 to the power minus 34, 3 into 10 to the power 8 over lambda, the wavelength of the radiation falling on the metal. Work function is given 4.30 electron volt. Careful, we need to convert to joules, because when you solve here you will get joule, but work function is given in terms of electron volt. To convert electron volt to joule, multiply by 1.6 10 to the power minus 19. So 4.30 into 1.6 into 10 to the power minus 19 plus half 9.11 10 to the power minus 31 is the mass of the electron into speed. So we found it 4.85 10 to the power 5 all in square. Find the lambda. So a lot of numbers, carefully solve it. Get the lambda, you will get 2.50 10 to the power minus 7 meters. Okay, now the wavelengths are given in nanometer. Nano means 10 to the power minus 9. So to convert to nanometer, 2.50 will become 250 into 10 to the power minus 9 meter. that is 250 nanometer. Now check the table. There's a small table given which this wavelength falls within which range. You can say ultraviolet C type is between 200 to 280. Ultraviolet B is 280 to 320. Ultraviolet A is beyond that. So 250 is falling within UVC. So the radiation used is ultraviolet C. Okay, so the last part of this paper. So a graph is given, that is kinetic energy of the fastest electron against the frequency of radiation. A student used a zinc plate. UV light of different frequencies is an experiment. The student's graph of maximum kinetic energy of the released electrons against the frequency of UV light is shown. Einstein's photoelectric equation also given. We know that HF equals 5 plus half mv squared max, that is the kinetic energy maximum. Describe two ways that the graph is not consistent with the values known for a zinc plate. Your answer should include calculations. Work function of zinc is given in electron volt. Okay, so first we'll think about the graph. So the graph is given. So that means the photoelectric equation HF equal 5 plus half mv max squared, that is, it's drawn on the y-axis. So half mv max squared is equal to HF minus 5. So the graph is plotted for half mv max squared against the frequency, means I can say this is on the y-axis, this whole thing is on the y-axis. This is y equal, this should be the gradient. This is the x-axis, frequency is the x-axis. So the gradient should be equal to Planck constant minus phi. This is the work function, the y-intercept point. So if you extend this graph, but that is not given, no space also given, difficult to find it. But if you extend this graph where it cuts the y-axis, will be equal to work function of the metal. But here they are saying this graph is not tallying with the work function of the zinc plate. Okay, so what we do? Two reasons we need to give. First, we will find the gradient. So gradient must be equal to Planck constant. We'll find the gradient from the graph. It's on a grid. So we'll find the gradient. So gradient, that is m equal, I took two different points, that is 10 and 2 I took it on y-axis, the point 10 and 2 I took it. So those are in electron volt. We have to convert to joules. So 10 minus 2y2 minus y1, that is in electron volt. So I need to convert to joules. So multiply by 1.6 10 to the power minus 19 y2 minus y1 over x2 minus x1, because Planck constant is in the unit of joule second. Right, so I need to convert it in the form of joule, not in the electron volt. So that's the reason I multiply by 1.6 10 to the power minus 19 divided by x-axis frequency 15 minus 9. So 15 minus 9 into 10 to the power 14 into 10 to the power 14. So I get 2.13 into 10 to the power minus 33. So joule second. Okay, y-axis is, I converted joule. This is frequency per second. So joule second. But we know that the gradient must be equal to Planck constant. The Planck constant, but Planck constant H equals 6.63 10 to the power minus 34 joule second. So I can say since the gradient is not equal to, it must be equal to Planck constant. When I plot a graph of height half mv max squared against frequency, the gradient must be equal to Planck constant, but I'm getting some other answer, so that means there's a mistake. Okay, since the gradient is not equal to h, it is not consistent. First reason. So second reason I can say, they have to show two reasons. So second reason I can say here, the graph where it cuts the x-axis should be equal to, you know that, it must be equal to threshold frequency, because at the point where it cuts, you can see that the y value is 0, the kinetic energy equal to 0. So you can see that HF equal 5 plus KE max or half mv max squared. So where the graph cuts the x-axis, see the graph, where the graph cuts the x-axis, the kinetic energy is 0. So kinetic energy 0 means HF equal, this is 0, this is equal to 5 equal HF naught. You know that work function equal to HF naught, F naught is the threshold frequency, HF is the frequency. So H and H will get cancelled. So the frequency must be equal to threshold frequency. So from this I can say the frequency, the value of the frequency where it cuts the x-axis must be equal to threshold frequency. So that is equal to how much? 7.5 Hertz. So if you want, you can derive and show that, but it's a common thing where the graph cuts the x-axis should be a threshold frequency. But we'll find the threshold frequency. We know that we can calculate the threshold frequency by using work function, and we'll compare that threshold frequency with the point where the graph is cutting the x-axis. So just I did this to make you to understand the graph where it cuts the x-axis must be equal to threshold frequency. You can use it directly, that one. So we'll find the threshold frequency by using work function phi equal HF naught. So phi is given, the work function is given 4.30 electron volt, 1.6 10 to the power minus 19, 6.63 10 to the power minus 34 into F naught. Find the F naught here. So when you find the frequency F naught, you will get that will be equal to 1.04 into 10 to the power 15 Hertz. But you can see the point where the graph, the x-intercept point, equals 7.5 10 to the power 15 Hertz, which is not equal to threshold frequency. Therefore, the graph is not consistent. Consistent with the work function of zinc. Values of zinc, yeah. Okay, so where it cuts must be equal to work threshold frequency, but we know the threshold frequency calculated from the given work function, but the graph is cutting at 7.5 10 to the power 15 means it's a wrong data. He has to find two different reasons, so these are the two reasons for the C part. Okay, I hope you understood. In the description part, I will give the link or the URL for the other unit 2, my unit 2 discussions, so that will be given on the description of this video. Okay, bye.